All right, I want you to skip in your notes the first section, 8.1, and skip straight to section 8.2 about the Pythagorean theorem. We're going to skip that first section. It's a bunch of junk that nobody needs and doesn't really matter ever. So we're going to start right into talking about the Pythagorean theorem. And you know the Pythagorean theorem works with right triangles. So hopefully you remember that the legs of the right triangle are the sides. So this is a leg and this is a leg. And the hypotenuse is the side opposite the right triangle. It's also the longest side. So here is the hypotenuse. And remember, it said that the hypotenuse is opposite the right angle. So if this is the right angle, opposite means it's across the triangle from it. Opposite is going to be a big important word for us in the next week or two. Okay, so the Pythagorean theorem, which you've seen before, is used to find the missing side of a right triangle when you're given two sides. It only works on right triangles. And you remember the Pythagorean theorem as a squared plus b squared equals c squared. And that's when you're looking at a right triangle, the two legs are a and b. It doesn't matter which one is which. All that matters is that the side opposite the right angle is the c. That's the hypotenuse. So we're just going to get right into making sure we can do this thing. So first example, solve for the missing side. So the first thing you want to do is identify where the hypotenuse is. So that's your C. The other two sides, doesn't matter which one is A and which one is B. So our Pythagorean theorem says that A squared plus B squared equals C squared. So 9 squared plus 12 squared equals X squared. And we get 81 plus 144 equals X squared. So 81 plus 144 is 225. Okay, and now the way that we undo this, which is why we've been practicing all these square roots, when you have an x squared, if you square root both sides of it, that removes the squared. So now we'd have x equals, and it's whatever the square root of 225 is, which hopefully you've memorized by now, is 15. So our missing side is 15. Not too bad. We'll come over here and try another one. So we've got a squared plus b squared equals c squared. So a and b don't matter. They can be either of the two legs. The opposite of the right angle is the one that's important. That's our c. So 12 squared plus 32 squared equals x squared. Now 12 squared is 144. 32 squared, you're probably going to have to get the calculator out for that one. That is 1024. So 1024 plus 144 is 1168. And that equals x squared. Now, your instructions say simplify your square root if possible. So we're going to simplify it and get x equals the square root of 1168. So we're going to take 1168 and it's way too big. So we're just going to start and divide it by 2 and get 584. So we'll divide that by 2 and we get 292. And then we'll divide that by 2 and we get 146. We'll divide that by 2 and we finally get down to 73. Now 73 is not a number we can break down anymore, so we can stop there. We've got a set of 2's, a set of 2's, so we take both those 2's out of the house, so that's going to be 4 square root of 73 equals x. So that's a simplified square root. A lot more practical application of this is just going to be to type 1168 in your calculator and square root it, and you would get that 34.2 is your x. And you can check that, make sure it's right, because 34 is bigger than 32, and it's bigger than 12. And remember, our longest side had to be the hypotenuse. So, all right, so another thing that we've looked at before and we're going to revisit again is called the triangle inequality theorem. And it just says that when C is the longest side, which is what we're always going to be dealing with, when C is the longest side of a triangle, if C squared equals A squared plus B squared, then that triangle is a right triangle. And if you remember, we've done this before, so we're going to go pretty fast. If C squared is greater than A squared plus B squared, that's an obtuse triangle. And if C squared is less than A squared plus B squared, that is an acute triangle. So we're going to come down and check our three examples. They say, tell if the measures can be the side lengths of a triangle. So you'll remember how to do this. You take the two smallest ones, and you make sure they're bigger than the third one. So we're going to do it with all of them. Two smallest ones, bigger than the third one. Two smallest ones, bigger than the third one. So we're good. So now we're going to do C squared, and we're going to see if it's bigger than, smaller than, or equal to A squared plus B squared. So longest side, 14 squared. We have 9 squared plus 12 squared. 14 squared, you've memorized, is 196. 9 squared is 81 plus 144. So 196, 225. 196 is less than, so C squared was less than, which means this is an acute triangle. All right, 34 squared. Oops. 17 squared plus 18 squared. So 34 squared is 1156. So we can just type 17 squared plus 18 squared right in our calculator, and it gives us 613, which is clearly less than 1156. So the C squared is greater, which means this is obtuse. And our last one, we're going to do 13 squared and compare it to 5 squared plus 12 squared. So 169. 5 squared is 25 plus 144 is also 169. So those are equal. So that makes this a right triangle. So try to make that quick for you. Know these facts about the Pythagorean theorem and you will be good to go.